Hey, welcome back everybody. This is Mr. Oliver. I'm going to go ahead and start today's topic, which is going to be solving area problems and circumference problems with circles. And we're going to try to keep our answers in terms of pi. And I'll talk more about what that means in the lesson coming up here. But in terms of formulas, I'm not teaching anything new. We've all gone over circumference, and we've all gone over area of a circle. So we're just going to talk about different ways to apply that formula, especially with keeping it in terms of pi. And that's what we're going to do. All right, now before we get too deep into these notes here, let's kind of just make sure we know the formulas for circumference and formulas for area of a circle. And let's just kind of make sure we have these written down. The formula for the circumference of a circle is pi times diameter. Pi times diameter equals circumference, C for circumference. So know that formula. I mean, you can also use 2 times pi times r. That also works as well. But this, I would say that formula right there, pi times diameter, is the most commonly used expression. That's the most commonly used formula for finding the circumference, the perimeter of a circle. Now, the area of a circle, that's the thing that we just did last week. That is going to be pi times radius squared. Pi r squared, you sometimes hear that referred to as, but that equals area, A for area. Okay, so pi times radius squared, and make sure you remember that r squared does not mean radius times 2. What does that mean? That means radius times radius. Okay, so how do you express your solution in terms of pi? This is the new topic today that I'm referring to, and an alternative approach to keep pi. This is what we're going to talk about here. An alternative approach is to keep pi as part of your solution instead of estimating to a number, to the number forms. So we usually estimate it to 2 decimal places, but if you want to, you can go even further. You can go 3.14159226. You can keep going and going and going. But or you can use your pi button on your calculator. But what we're going to do is, this is going to be a very algebraic way. We're going to keep pi intact, which sounds weird. But we're going to keep that pi intact, meaning we're not going to multiply anything times this number. We're going to leave that pi the way it is. Pi is going to be just pi. So here, let's kind of go through some examples here, and you guys will know what I'm talking about. So the first example here says, find the circumference of the following circle. Express your solution in terms of pi. Okay, so for this question right here, we're looking for circumference. So we're going to use the circumference formula, which is pi times diameter. And for this one, we're going to do, now we're not going to turn pi into a number. We're just going to keep pi as the symbol, for the Greek letter P for pi. And we're going to multiply that by the diameter. Now that number right there, that is not the diameter, that's the radius. So the diameter is going to be double that, right? Remember, the diameter goes all the way across the circle through the middle. So that's 12 feet right there. Let me show you how easy this is. I mean, this is almost like, it may seem like you might want to go back in your notes and go, did I hear this right? And it really is easy to keep things in terms of pi because it's very algebraic. Like when we, let me kind of remind you, like if we do 5 times x, what have you learned about that? Well, you know that that's 5x. You've learned that, 12 times g is 12g. We've learned that 19 times y is 19y, right? We've all learned that. And it doesn't matter where the letter is. I should make sure I show this too. Like, let's say I have h times 15. That's going to be 15h. 15h. You don't want to write h15. That's a very atypical way of seeing it. But yeah, 15h. And we're going to treat y just like we do these variables, like g and y and h. We're going to treat the pi symbol exactly the same way. So what you're going to do is, just put those together. So 12, or pi times 12, is 12 pi. And that's it. You don't have to do anything else to that. So 12 pi, I actually should write it like this. 12 pi feet. 12 pi feet. Now, actually, if you think about it, that's a very accurate answer. because whenever we change pi to a number, 3.14, are we being exact? Not quite. Remember, that's an estimate. That's a rounded figure. But if we keep pi as pi, it's, it is what it is. You just leave it the way it is. And sometimes leaving that pi in there is an easy way to keep it. And I think maybe this rang a bell with you, that this was kind of easy. But that's really all there was to it. So 12 pi feet. Now that was circumference, so we didn't have to put feet squared. On example B right here, it says find the diameter and the radius of the following circle if the circumference equals 18 pi. So we've got, again, we're using circumference formula, which is pi times diameter, and that's going to equal circumference. So this time around, we have the circumference. We don't know what the radius is. We're not sure what that is. And we're not sure what the diameter is either. So what we're going to do is we're going to put the numbers into the circumference formula. So pi times diameter equals 18 pi. So what's pi times diameter? Well, that's d pi. And hopefully this is a little bit of algebra, but again, this is nothing that we're doing is too crazy complicated here. Now, if I want to get d by itself, I'm going to divide both sides by pi. And let me just show you what happens here. Now that pi cancels with that pi right there. And what are you left with? We're left with d on that side, diameter. D stands for diameter. And these pi's right here, those cancel out. So the diameter equals 18. Now, a lot of you might have been thinking, like, I didn't need to go through all that, which I totally agree with. But I'm just showing you the algebra, of course, because as a teacher, I have to kind of show you these things. But a lot of people, when they see these problems, they're like, oh, if the circumference is 20 pi, then that means the diameter is 20. You're absolutely right. If the circumference is 53.4 pi, well, that means the diameter is 53.4, whatever the units are. So you can make that generalization with these. I don't care. But I was just showing you why that is the way it is. So we've got diameter of 18. D equals 18. This one doesn't give a unit, so I'm just going to say 18 units. And it also asks for the radius. So the radius is half the diameter, so the radius means it's got to be 9 units. All right, now moving along to example C. Here it says at Fermilab, which is right next door to Warrenville. I don't know if you guys ever go to Fermilab or drive through there or ride your bikes through there. I would highly recommend it, especially since you guys have got the time. And there's buffalo in there, and there used to be elk, but I don't know if those are still there. But at Fermilab, it says the Tevatron is approximately 1.24 miles across. If you and your friends want to take 4 laps around the Tevatron, how far will you travel in terms of pi? Yeah, so here I just pulled up on Google Maps really quickly the Tevatron. The Tevatron is the name for the particle accelerator that is in Batavia, which is, like I said, right next door to Warrenville. Right there that's where Warrenville Road is, right there on the map. If you ride your bike down that road, or maybe some of you live down that road, you might live close to there. You've got one of the world's biggest science experiments just, bike rides away. If you think about it, this particle accelerator, what this thing, I'm not a physicist, but I do love this place. And this Tevatron, what it does is over here is an electron is sped up to like super speeds, like 99% the speed of light or something like that, or pretty close to it. So yeah, like an electron beam is accelerated, it gets faster and faster and faster and faster, and then it's spit out into the Tevatron, which is, these huge magnets, and then it's rotated around this, and I'm not doing that perfectly, of course, but it's rotated around this Tevatron at lightning fast speeds, and then eventually the thing is kicked out, and then the electron is smashed into pieces, into smaller pieces, and that's where they're basically looking up, that's where if you have any family members or anybody that works at Fermilab, you might know that they've discovered new particles that weren't known before. It's a super cool place. The thing I was trying to talk to you guys about is, all right, I don't think you're allowed to do this. which I wouldn't recommend doing. I don't think you're allowed to walk across it. I think these are kind of off limits, but I do believe you can there's roads and trails around there, but you can ride your bike around it, but I don't think you can walk across it. This is a pretty good sized circle, so if we're looking what it is across, okay, if we know what that distance is across, then, we should be able to use the circumference formula to figure out the distance around. So let's do that. So if we're looking for how many laps we can make around this tevatron, around the circle, we're going to use the circumference formula, which is pi times diameter equals circumference. It says that the tevatron is approximately 1.24 miles across. Now that sounds like it's describing the diameter. So we're going to do pi times 1.24, and then we're going to make that equal to the circumference. So circumference, essentially, I know this seems too easy, but it is this easy. Pi times 1.24 is going to be 1.24 pi. So I'm going to put 1.24 miles. That's what that is, 1.24 pi miles. Again, this has not been multiplied. We're not doing, if we want to, we could, but we're not doing 1.24 times 3.14. I didn't ask you to do that. I'm asking you guys to keep pi intact, to keep just pi what it is, almost like an x or a y or whatever letter you guys want to use for a variable. So that's the distance right there. What we just found there is we just found the distance one time around the tevatron, around that loop, around that circle. So what we're looking for here is we're looking for 4 laps. So we're looking for 4 laps here. So what we're going to do is we're going to do 1.24 pi and multiply that by 4. So you're just going to do 1.24 times 4. Now I know I've taught you guys something about like terms, but when it comes to multiplying, like terms don't really exist. You can multiply anything times anything when it really comes down to it. So we can just do 1.24 times 4, which is 4.96. So 4.96 pi miles. Now, if you really want to figure out what that is, if you want to figure out like an exact or pretty close estimate as to what it is, yeah, go ahead and multiply that by pi, by 3.14. But I'm only asking you guys to keep your answer in terms of pi. So we don't really have to do that. We don't actually have to figure out exactly what it is. So this is good enough for our purposes, 4.96 pi miles. All right, for example D, it says a pizza with a diameter of 40 centimeters is placed on a pan that has a diameter that is 6 centimeters longer than the pizza. What is the circumference of the pizza pan in terms of pi? You don't have to draw a picture for this, but we have the pizza, and then we have the pizza pan. I'm sure I'm not drawing this to scale. There's the handle, I guess, maybe. But you got the pizza and the pizza pan. And it says that the diameter of the pizza is 40 centimeters. Pi times diameter equals circumference. So the diameter of the pan is 40 centimeters. But it also says that the pan is that it's placed on is 6 centimeters longer. So you're going to add 6 to that to get the pan. So what is the circumference of the pan? Well, we're just going to do this. We're going to do pi times 46, and that will equal the circumference. So what's pi times 46? And this is, believe me, it is this easy. It's going to be 46 pi, and we're going to put centimeters. 46 pi centimeters. I know that looks like a weird answer, but that's fine if we want to keep our answers in terms of pi. And this is probably something more along the lines of you're going to be doing a lot of this in 8th grade, but 46 pi centimeters is a perfectly fine and acceptable answer. Okay, for example, E here, it says a logger measures the circumference of the tree was cut down to be 24 pi feet around. What is the area, A, of the cross-section of the tree that was cut down? Give your answer in terms of pi. So it's basically asking, the tree was cut down and we're looking at the stump, we're looking at this area. And that's something, you can figure out. You can put a tape measure around it. You can measure it around, and we can figure out what that stump is right there. So logger measures the circumference around the tree, and the circumference is 24 pi feet. So pi times diameter equals circumference. Well, pi times d equals 24 pi feet. And I've just taught you that, if that's what it is, we can just divide both sides by pi here. Those cancel, and we're left with the diameter there. That's all that we're left with, is the diameter equals, these cancel, so diameter equals 24 feet. That's a pretty wide tree, by the way. Maybe it's a redwood or something, but it's 24 feet. Okay, now this question right here is asking, what is the area of the cross-section of the tree? So we're looking for the area of that stump, the area that's on top of it. So we need to figure out the area. So how do we figure out area? Well, we need to know what the radius is. So if the diameter is 24 feet, the radius is going to be half that. It's going to be 12 feet. The formula for area is going to be pi times radius squared. So we're going to leave pi the way it is. We're going to leave pi intact. Don't mess with it. Don't change it to 3.14. Don't press your pi button. Just pi is going to be pi. And then we're going to multiply that by 12 squared, because the radius we've determined to be 12 feet. So 12 squared is going to be 12 times 12, which is 144. So I'm going to write 144 pi equals the area. And now to be even more specific, we're going to write it in the right units. So 144 pi feet squared, because this is area. So 144 pi square feet. And we're, like I said, we're keeping that pi in the answer. If you want to multiply it out and figure out exactly what it is and get it to the closest tenth or hundredth or whatever. But this, believe it or not, is a very accurate answer as long as you don't multiply by pi. Because like I said, if you're multiplying by pi, you're multiplying by an estimate. If we keep pi the way it is, we're not estimating. We're keeping that as the keeping that as a geometric constant that we know it as, which is 3.141592653. All those numbers that keep going and going and going and going. All right, now this last example I think is a really good example for showing why keeping pi intact is a good idea, because there's a lot to this, and you'll kind of see as we go along why it makes sense. And let's kind of just get started here. It says find the area of the shaded region. Each circle is congruent. That just means each circle is exactly the same. They both have the same diameter, same radius, same circumference, all those things. And we want to express the area in terms of pi. Now this is a good question. This has got some interesting parts to it. Now this circle right here, or this problem right here, some people, when I've done this in the past, they've said, you know what, there's missing information here. It's not giving me enough information. But you know what? A lot of math problems, if you ever notice, a lot of math problems give you just enough information, right? And the other part that you have to figure out is, that's the part you have to figure out and use some good critical thinking and problem solving skills to figure it out. But it says that that's 8 inches. That's 8 inches right there. So if that's 8 inches, what's that telling you? Well, it's also telling you the diameter of that circle. So the diameter is also 8 inches. Well, if it's a diameter, it should be 8 inches no matter where you look at it across. That's going to be 8 inches, right? That's going to be 8 inches. Everything's going to be 8 inches as long as you're looking at diameters. So this should also be 8 inches. So that's 8 inches right there. And then we can assume, since these circles are congruent to each other, we can assume that that circle is also 8 inches, which in turn tells us what the total length of that rectangle is, which is going to be 16. So knowing that diameter, like I said, knowing the diameter told you the length of the rectangle, because the two circles are end to end, and they're touching each other at the diameter, and they're both exactly the same, and they're both 8. So 8 plus 8 is 16. So hopefully you understood what I did there. Now, we didn't finish this problem by any means, but we did figure out some of the important information there that will definitely be important to know in order to figure out the area of the shaded region. Now, if you want to find the shaded region, this is one of those problems where you're looking for a negative space, okay? So what you could do is you could imagine, I'm not drawing this to scale, but it was a complete rectangle at one point, right? It was a complete rectangle. It was all shaded in. I know it's shaded in green, but it was all shaded in. And then someone came around and they cut out 2 circles. Now those circles, what do they do to the overall area? Well, they take away from the area. They are going to subtract from the overall area of that rectangle. So what you're going to want to do for this problem is you're going to want to find the area of the rectangle, and then you're going to want to subtract something. What do you want to subtract from that? Well, we have the area of a circle, but we don't just have the area of one circle. We want to find the area of both circles. Running out of room here. So area of 2 circles right there. So we're going to do area of the rectangle minus the area of the 2 circles. And this one says we want to keep it in terms of pi. So the area of a rectangle is going to be a matter of doing 8 times 16. 16 times 8, which is 128. I can put 128 square inches right there. And then the area of the circle is going to be a matter of doing, well, there's 2 circles here. So let's kind of put it off to the side here. So we have 2 circles. So we're going to do 2 times pi times radius squared. Right? That'll be the total area of both the circles. So again, we're leaving pi the way it is. The radius of the circle, remember the radius of the circle is half the diameter. So we know that the entire diameter is 8. Right? We know the entire diameter is 8, so that means the radius must be 4. So we're going to do pi times 4 squared. And that will equal the area. So let's do parentheses first. So 4 squared is going to be 16, not 8, right? Not 8. And then pi times 16 is just 16 pi. And then 2 times 16 is going to be 32 pi. Now notice how we kept pi as part of the answer, and that's basically the overall theme here. You want to make sure you keep pi in your answer total. And so the answer, the area for that one is going to be 32 pi inches squared. Here comes like one of the more confusing parts about this. And you're going to be very tempted to take 128 and subtract 32 pi, but you cannot. Those are not like terms. Now remember, like let's say, let me just kind of change the makeup of this problem a little bit. Let's say it was 128 minus, instead of 32 pi, let's think of it as like 32x. Now way back when we talked about like terms, those are not what you would call like terms. This is a constant. This is a coefficient with an x attached to it. Those are not like terms. The only thing you can add or subtract to 32x would be another x. The only thing you can add to a constant is another constant. So believe it or not, I know this seems kind of weird, but the answer is going to be 128 minus 32 pi, and I'm going to keep that in parentheses, inches squared. That's what it is. Now, if we wanted to figure out exactly what that area was, we could just plug in 3.14 for pi and just kind of calculate it out. But since again our topic today is to try to keep things in terms of pi, that's all we had to do. So we have 128 minus 32 pi square inches. Now it's a little bit of a nutty problem there, but that was definitely a good one. Definitely makes you think there. All right. So hopefully everyone understood this lesson. The topic was try to keep pi as part of the solution. Keep your answer in terms of pi. And that is it. So everyone have a great day, and I'll see you later. Take care.